to linear polynomials. Let's look into the introduction to exercise set 2.1. Overview of some of the terminologies that are being used under the polynomials. These are some of the examples through which we can understand what are the different terms of an algebraic expression are. Let's look into example 1. Raju went to a shop where there are sealed boxes of different colors on sale. The shop owner told him that the red boxes have 4 pence each and the blue boxes have 5 pence each. So what is the information given? We have some red boxes and some blue boxes. So the red boxes, how many pens are there? It has 5 pens in each of the red box and each blue box has 5 pencils. Now, if Raju bought X red boxes and Y blue boxes, how can he quickly figure out the total quantity of pens and pencils? Also, if he got 3 extra pens free, how many pens and pencils did he get altogether? Now, let's look into the solution for this. There are X red boxes. So, how many pens do we have from the red boxes alone? We know that each of the red boxes have 4 pens each. We have X number of boxes. So the total number of boxes, total number of pens that are found only in the red boxes will be equal to 4x. Similarly, for Y blue boxes. So how many blue boxes do we have? We have Y number of blue boxes. And how many pencils do we have in each of the box? We have 5 pencils in each of the blue box. So how many pencils do we have only in the blue boxes? We have 5 Y pencils. Also, it got 3 extra pens free. So how do we determine the total number of pens and pencils that Raju got? It is nothing but 4x plus 5y plus 3. This is nothing but representing the numbers in this format is called as an algebraic expression. Okay, so let's look into each one of the units which are found in this algebraic expression. What all do we find? We find 4x, we find 5y and 3. We find the operator plus in between. So each one of this, like the 4x, 5y and 3, they are called the terms of the expression. How do we identify the terms of an expression? We identify the terms by the units which are separated by the operators plus or minus. We do not consider the product or the divide when determining the terms of the expression. Only the operators plus and minus are considered. Now, x and y are letter numbers. 4 and 5 are the coefficients of x and y. If you look into 4, it is the coefficient of x. If you look into 5, it is the coefficient of y for this particular algebraic expression 4x plus 5y plus 3. So, but we have one more term. What is that? It is 3. But it doesn't have any variable like x or y. It is a constant number by itself. So, numbers like this in an algebraic expression, you call them constants. So, for these 4x, 5y, so how do we call these letter numbers? We have already seen that x and y are letter numbers. So, how do we call them? We call them variables in the language of polynomials. Thus, in the expression 4x plus 5y plus 3, we say the variables we have used are x and y and the constant is 3. Let's look into an example, the example 2, to have one more clear understanding on how the polynomials or the algebraic expressions are represented. A rectangular garden of length L meters and width W meters has to be fenced and decorated. A wire fence is to be laid along the length costing 100 rupees per meter and a wooden fence to be built along the width costing 80 rupees per meter. Special seeds have to be sown throughout the garden which will cost 50 rupees per square meter. So what all information are given for this particular example too? We have a rectangular garden a specification that the garden is rectangular in shape. Immediately, we should think about the length and width of the rectangle. So, what are the measurements that are given? The length is L meters and the width is W meters. Now, what has to be done? It has to be fenced and decorated. Fencing, where do we put? It normally runs along the length and along the width, right? So, how are they fencing it? A wire fence is to be laid across the length. So, across the length, it's a wire fencing. It costs around 100 rupees per meter. Along the width, it's a wooden fence. It costs around 80 rupees per meter. So, only along the length and the width, they are laying the fence at a different cost for the length and width. So, what is the total total cost incurred for fencing along the length? It will be 100 L. Right. Now, it is for one of the length. We know in a rectangle we have 2L. So, along the length, what is the cost incurred? It is 200 L. It is the cost of fencing along the garden length. Similarly, the cost of wooden fencing along the garden width is nothing but 160 width W. That you can very well understand. Now, one more information is given that the seeds are to be sown throughout the garden. Where do we sow the seeds? We do not sow along the fence. We sow it throughout the garden, which means the space that is covered for sowing the seeds is the area, right? So the cost of sowing seeds throughout the entire garden, it entirely depends on the area. What is the area? We know that length times width is the area. So for 1 square meter, it is 50 rupees. So for LW area, what is the cost? It is 50 LW. Now the total cost is the addition of all these three. Now this addition of these terms is the algebraic expression. We are trying to, what is our intention? Our intention is to indicate or to demonstrate the values given in terms of an algebraic expression. So, what all things should come into mind? The coefficients, the variables, the operators, all these things are to be kept in mind when we give an answer in terms of algebraic expression. Now, let's look into think and reflect. Can you identify the terms, variables, and coefficients in this algebraic expression? What are the terms? 200L is one term, 160W is one term, 50LW is the third term. All these three terms are separated by the operator plus. How is it different from the algebraic expression in example 1? In example 1, what is the algebraic expression? We had 4x plus 5y plus 3. It had three terms. Example 2 also has three terms, and we had two variables. Example 2 also had two variables, and example 1 had a constant which is not seen in example 2. So these could be the differences between example 1 and example 2. Now let's look into example 3. A wire of length 20 centimeters is bent in different ways to form rectangles. Now we have a wire of length. It is just bent into different rectangles. So one with length 7 centimeters and width 3 centimeters. So the other one, the dimensions are 5.5 and 4.5. Think of a few more ways of forming such rectangles. Can you write an expression for the area? So whatever be the value of the length and the width, how do you find the area? Area is what? L into B or L into W. So if the length we consider is x centimeters, what information do we have? We have a wire of length 20 centimeters. Now this 20 centimeters, we have to divide it into 2 so that the width becomes 10 minus x, right? The length is 2x, the width will be 2 times 10 minus x to compensate for the length 20 centimeters. So the expression for these area of these rectangles is x times 10 minus x or 10x minus x squared. Now similarly for this, what could be the terms, variables and coefficients? The terms are 10x and x squared. It is separated by the operator minus. The variables are x and x squared. The coefficients are 10 and minus 1. Can you find out the similarity or difference between the algebraic expressions obtained in 1 and 3? The similarities are that the difference could be, we have the example 3 is a polynomial of degree 2. What is a degree? It is the um, highest power in a particular polynomial. So this could be one such difference. And example 1 is always of power 1, but example 2, the highest power is of power 2. And the difference, one more difference is that example 1 has a constant, example 2 doesn't have. Right, we are looking into some of these algebraic expressions and trying to understand the types of polynomials. So the polynomials, how do we differentiate? One is based on the number of terms. We have already understood what are the terms in a polynomial, and other is based on the degree. So the highest power, power in a polynomial is the degree of the polynomial. So based on the degree as well, we can differentiate the different kind of polynomials. So this is consolidated in this particular tabular column. So based on the number of terms, what are the different types we have? We have monomial, where it can have only one term. See this example 4x. There is only one term. For binomial, it is 2y minus 1. What are the two terms? Bi means 2. So what are the two terms? It is 2y and 5. This is a trinomial. What are the terms? X squared, 5x and 1 are the three terms. So it is called a trinomial. More than that, it's generally called a polynomial, as it is indicated by the example number 4. Now, based on the degree, how do we classify? It is called linear, quadratic, cubic or constant. More than that, like the highest powers could be 4, but to our knowledge, we are restricting ourselves to 1, 2, 3 and 0. So if it is 1, it means the highest power is 1, the degree is 1. Quadratic, if it is, see, if you can look into this example, x squared plus 5x plus 1, what is the highest power? It is 2. So it is you call that a quadratic. If the highest power is 3, you call it a cubic. Now, just a constant number, number 16 or any other number, you call it a constant polynomial. Why? The variable included with this particular example could be x to the power of 0, or anything to the power of 0 makes it 1. So, since the degree is 0, you call it a constant polynomial.